Today we're going to be talking about solving systems by elimination. So this is our last method that we're going to talk about dealing with solving these systems. So far we've talked about graphing and substitution. With elimination, the word elimination actually kind of tells us what we're trying to do. So elimination is another word for kind of canceling. So we're looking to cancel out a variable. That way we're left with just one of our variables that we can solve for. So to do this, we do need our variables to be lined up. What we mean by that, if we look at the first example here, is my x's are above each other and my y's are above each other, and then my numbers are with each other as well. So it doesn't really matter what form these are in, as long as I have the x's and the y's kind of all lined up, as well as those numbers. Okay? The other thing I need is one of the two variables must have opposite coefficients. So opposite coefficients are referring to those numbers in front of the variables having the same number but the opposite sign. So if I look at number 1 here, the 3 and the negative 3 on the y are those opposite coefficients. Okay, a coefficient in general is just the number in front of this variable. Okay, so for our hint here, what we're looking for is to have the same number with opposite signs in front of one variable. Okay, and it does have to be in front of the same variable. I can't have it in front of one x and one in front of the y, or I'm just not going to get things to cancel out the way I need to. Okay, so with the first one here, if we look at example 1, I have two equations, my x plus 3y equals 14 and 2x minus 3y equals negative 8. And what I'm looking for is to get these y's to cancel, which I have that positive 3 and negative 3 that I know when I add them together and then cancel. So I'm just going to take these two equations and add them together. When I add these equations together, what I'm really doing is adding them kind of like the old-fashioned way of doing addition that you learned all the way back in elementary school. I'm just adding kind of straight down all of my more or less columns that I have with my variables. So I have an x plus a 2x, which is going to give me 3x. 3y plus negative 3y gives me a plus 0y. We'll talk about that more in just a second. And I have 14 plus a negative 8 gives me a positive 6. Okay, from there, this 0y doesn't actually mean anything. It really canceled out. Okay, I don't have to have it. So if I ignore that, I have 3x equals 6y. I can go ahead and just divide by the 3 on both sides, and I have x is equal to 2. Okay, at that point, I've found my first variable. To get the second one, I'm going to do the same thing we did with substitution. I know one of my two variables now. I can plug it back into one of my two equations and solve for the other one. So I'm plugging 2 in for x, and I'm going to go into the first equation here, plus the 3y is equal to 14. Okay, from there I can subtract my 2y from both sides. Our 2's will cancel. I have 3y is equal to positive 12. Divide by your 3 and divide by your 3. Y is equal to 4. Okay, at this point I know both my x and my y coordinate. The last thing I want to do is assemble those into a coordinate pair or an ordered pair so that I have that single point. That would be my solution. Okay, let's move on to number 2. As we start to move into these other ones, we're going to see that we're not always given something that starts out with those opposite coefficients. And so with number 2, I have the same coefficient on my x's here, but they're not opposites. I really need one of these to be negative. So the way to do that is I can manipulate one of these entire equations by multiplying it. And I can multiply it as long as I multiply both sides of the equations. If I do the same thing to both sides of that equal sign, I'm allowed to do it. So I'm going to take this bottom equation here, and I'm going to multiply the entire thing by negative 1. Okay? Now that first equation, I'm not going to change at all. So I'm just going to bring that down. 2x plus 2y is equal to 4. The second one I'm going to actually multiply through by that negative 1. So negative 1 times 2x gives me negative 2x. Negative 1 times 3 gives me negative 3y. Negative 1 times 7 is the negative 7. Okay, again, I'm going to add these together. And this time my x's are going to cancel. And it doesn't matter which variable cancels as long as one of the two cancels. It can be either x or y or whatever variable we're using. For my y's here, I have 2y and a negative 3y. It gives me negative 1y is equal to negative 3. Then I can go through and divide by my negative 1 on both sides, and y will equal 3. Okay, again, last thing is to plug that back into my first equation. So I'll have 2x plus 2 times 3 is equal to 4. And again, it doesn't really matter which equation I plug into. This one I decided to go all the way back to the first one, but it doesn't actually matter. Okay, if I do that, I have 2x plus 6 is equal to 4. I can then subtract the 6 on both sides, and I'll have 2x is equal to negative 2, divide by 2, divide by 2, and I have x equals negative 1. If I assemble my coordinate there, be careful with the order that you put those in. X goes first, then our y. Doesn't matter what order we found them in, x is always first. So negative 1 comma 3. Moving on here to number 3. And number 3 is going to be a little bit tricky as well. If I look at this one, I have 3x plus 2y equals negative 26, and 2x minus 6y is equal to negative 10. Now, in order to get things to cancel here, I need those opposite coefficients. So I need the same number but opposite sign. If I look at my y's, I have my opposite sign. I have one as a plus and one as a minus, or a negative, but I don't have the same number. Okay, I have a 6 and I have a 2. So what I'm looking for is, can I take one of those two numbers and make it match the other one? Okay, the easiest way I would say to do that is take the smaller one and try and make it match the bigger one. So I would take the 2 and try and make it match the 3, or the 6. The way to do that is to use a 3 and multiply the entire top equation by 3. So let's go ahead and do that. 3 times 3x gives us 9x. 3 times 2y gives us 6y. Is equal to 3 times negative 26 is negative 78. Then we'll do 2x minus 6y is equal to negative 10. And we'll go ahead and add those together. 9x and 2x gives us 11x. Our 6y's cancel. One's positive, one's negative. And our negative 78 with a negative 10 gives us negative 88. Okay, from there I'll go ahead and divide by the 11 on both sides, and we'll have x is equal to negative 8. Okay, last one's to plug in that negative 8 for one of my two variables. I'm going to go ahead and throw it into that first one. For some reason, I've just always plugged them into the first one. Doesn't actually matter though. You can plug it into the first or to the second. And that's going to equal our negative 26. Okay, 3 times negative 8 is negative 24. Plus our 2y is equal to negative 26. I need to get the y by itself still here, so I'm going to add the 24 to both sides. Not there, sorry, over here. Which gives us 2y is equal to a negative 2. Divide by your 2 on both sides, and y will equal negative 1. And if I look at my coordinate there, I then have negative 8, negative 1. Okay, and then the last one we're going to talk through here real quick is number 4. Number 4 is probably the trickiest one. It can get a little trickier from here, but this is about as hard as I can make it. Okay, if we look here, I'm looking for those same numbers with the opposite signs. So if I look, I don't have any of the same numbers. I do have some opposite signs here on the y's, which tells me if I'm going to pick which one to kind of mess around with, I'm going to try and get those y's to match. Okay, so I need to get a 5 and a 2 to match each other. Now before with number 3, we were able to take the 2 and multiply by 3 to get 6. Here, I can't multiply 2 by anything to get 5. Well, not a whole number at least. We're going to try and stick to whole numbers as much as we can. So instead, I'm looking, well, is there a number that I can multiply each one of these to get to? And so what I'm looking at with a 2 and a 5, I know those both go into 10 pretty easily. To get to that 10, I would have to take this first equation and multiply it by a 2. And to get to the 10 for the second one, I would have to multiply it by a 5. Okay, and again, I'm allowed to multiply each equation by whatever I want. It doesn't have to be the same for each equation, as long as I multiply through the entire equation by the same thing. So if I'd use 2, I got to multiply everything in that first equation by 2. Same thing with the 5 for the second equation. Everything needs to get multiplied by that second 5. Okay. Now, when we do that on the first one, I'm going to go ahead and start multiplying here. 2 times 2x gives me 4x. 2 times 5y gives me the 10y I was hoping to get, and then 2 times 15 gives me a 30. And the second one there, 5 times 3x gives me 15x. 5 times negative 2y gives me negative 10y. And 5 times negative 6 is negative 30. Okay, from there I can go ahead and add these things together. My y's are going to cancel just like I wanted. 4x plus 15x gives me 19x. 30 plus a negative 30 gives me a 0. Okay, then I can go ahead and divide by 19, and I'm allowed to divide 0 by 19. It just gives me 0. And I always get the question the first time we get a 0 for a variable, is that okay? And it is. 0 is just like any other number. It's on our number line, it's on our graph, it's a possible answer that we could have for each of our variables, so that's just fine. Okay, I am going to take that 0 and plug it back in, which gives me 2 times 0 plus 5y is equal to 15. From there, 2 times 0 is just 0. Excuse me. So this whole thing is just going to become a 0 here, the 2 times 0. which means I don't actually have to write it because adding 0 doesn't change anything. So I'm just going to rewrite this as 5y is equal to 15. Then I can go ahead and divide by my 5, and I'll have that y is equal to 3. Okay, final thing there is to put it into a coordinate, and I have my answer. Alright, so that is elimination. Okay, hopefully that's making a little more sense now. Again, this is just one of our options as far as solving a system. Okay, as we move forward, we'll talk about why this one works for certain situations, but why other ones might be better in different situations.